Yes, students, continuation. We have started with Unit 4 due to some internet problem. I think the class withheld in between, and I was not aware, and I was continuously teaching you. So we'll start again. Let all students join, otherwise, they will interrupt our class in between. So I'm sharing my screen. We have stopped here. Students, I have mentioned that NOP instruction. Have you heard that? NOP. Yes, students, are you able to listen? NOP, okay. So that is one of the other way we can use. It's very easy. And I was about to ask you regarding what do you mean by 1T state? Yes, please reply. What do you mean by 1T state? The time delay. I have just started now. What do you mean by time delay? It is generally used in real time applications such as traffic light control, digital clock, process control, serial communication, or anywhere we need to keep track of time. We can use time delays. Here, what we will do, these time delays are of few seconds and can be generated with the help of executing group of instructions. We can use any of the instruction which we have studied. From those instructions, we can design our time delay group. Okay, a register is loaded with a number depending on the time delay. Depending on the time delay required, and then the register is decremented until it reaches 0. See, counter and time delay is one and the same thing, students. Not a big difference in that. 0 by setting up a loop with a conditional jump instruction. The loop causes the delay depending upon the clock period of the system as illustrated in the next sections. So we were discussing that time delays can be written in many ways. One of the very easy approach is to write NOP instruction. No operation. It will waste, it requires 4T states to get executed. So ideally, while writing in the program, if I'm writing NOP, it will waste 4T states of microprocessor. Clear, students? So that is one of the way which is not mentioned over here. I'm just telling you that instruction you can use. But I want to know that what do you mean by 1T states? We have discussed timing diagrams, machine cycle, T states, and the timing diagrams we have discussed very briefly. So, what do you mean by 1T states and how it depends on the microprocessor frequency? And what is the clock frequency of microprocessor? Please answer. I'm waiting. Please answer. The operating frequency of 885. What is a T state? Who will answer? Yes, students, should I dictate the names? Hemu, Komal, please answer. Ashwarya, what do you mean? What is the clock frequency of microprocessor? What we apply and at which pin we will apply?
One time period of frequency.
Now be louder. Who is answering? Please, your name.
Ma'am, one time period of frequency.
Your voice is not clear to me. Again, please repeat.
Ma'am, one time period of frequency of
Very good.
microprocessor.
Now I am getting the voice. 1 upon. Please repeat.
Time frequency of microprocessor.
Yeah. And what is the operating frequency of microprocessor? Yes, student. What is the operating frequency of microprocessor? भूल गए सब? Nobody remembers. क्या होती है क्लॉक फ्रीक्वेंसी? 2 मेगाहर्ट्ज या 4 megahertz? What is the clock frequency? Okay, 3, 4, 2, it depends. We can have any clock frequency in between that. So that was one of the way. Next way, timing delay using one register, two registers, or timing delay using counter. So this we will discuss. We have created a time delay loop. We have drawn a flow chart. We have written a small program which is very easy to understand. A count is loaded in the register and the loop is executed until the count reaches 0. The set of instructions necessary to set up the loop is also shown in the figure. This is same as your counters. Okay, I will set the counter. Here I am applying time delay. For applying time delay, I have to set the counter also. So I am writing this program. You can write your own program. It's very easy. Load delay register. Draw the flowchart in your copy. Load delay register. Decrement register. Is register equals to 0? Yes. Out of the loop? No, it will be in the loop. And what program? Just 3 instructions I will write. This is using 8-bit counter. You can see what is the value of the counter I have loaded here? Who can tell me the value of counter from the instruction?
And we
क्या है काउंटर की वैल्यू?
started with the 100 and we will decrement it until reach to the 0.
So value क्या है काउंटर की? I am not able to hear you. What is the value of counter? Type in the chat box. Value of counter. Is it mentioned in the program or not? Is it a 16-bit counter or 8-bit counter? Yes, Vishwendra Aditya, Vishal. Please answer. Okay, Shreya, Shubhanshu Yadav, what is the value of counter? Please reply in the chat box. Okay, और क्या आंसर्स हैं? Shreya, Shubhanshu, Manoj, where are you? Are you attending the class or just? Yes, I'm waiting for others also to reply. Yes, few students are very active, very good. And few students, after announcing their name, even they are busy. So it's an 8-bit counter and the value of the counter is FFX. That means the highest value of 8-bit range. 8-bit ranges from, we all know in hexadecimal, it ranges from 00 hex to FF hex. Okay. 8-bit hexadecimal number. So I have uploaded it to the maximum number, the highest number. So C is loaded with FFX. How many T states MVI instruction requires to execute MVI? It needs 4 T states, and to execute this C, FFX, it requires 3 T states. So total 7 T states are required to execute MVI instruction. And here T states are very important whenever you are writing a counter program or a time delay program. It's a separate unit of your course. That means one question will be asked from this topic. So you should know basic T states requirement. And it is not necessary to learn all the T states because I know it's not easy to remember. So we should know the logic of T states. Machine read cycle, memory read, memory write. We have discussed 7 different types of cycles over here. So if you know the basic logic, then it is very easy to understand the concept. Okay, students? ये प्रोग्राम समझ में आया या नहीं आया? Please tell me. Then I am decrementing. DCR requires 40 states. Then what I will do, I will check the loop. So if a theory question is asked, you have to mention all these points very clearly. Then J and Z loop. Jump if not 0. Jump if not 0 as I'm decrementing the counter. जैसे ही 0 आएगा, it will come out of the loop and it will execute the main program. So this is my subroutine. So if not, it will go again back to DCRC. Always this labeling is important. You can put the labels, but this label should be same. I'm using it here in the instruction, and wherever I'm placing that label, the label should be same. Many students, what they used to do, J and Z P, and there they will write it as Q. So that is a wrong way to write the labels. And every instruction will require labeling. Wherever it is changing its order, the label is the most important thing, and it should be same. Because in the program, I can use 3 to 4 labels. I can use 3 to 4 jump instructions. So every jump instruction will have its own label, and that label is to be placed properly at proper place with the same name. So overall T states कितने लग गए इस program में? बताओ जरा मुझे. How many total T states required in this program? Total कितने T states चाहिए? The time taken by this program for execution can be calculated with the help of T states. Or for J and Z instruction, why I have written 2 different values? What 10 signifies? Please answer. Yes, who can answer? I have shown this should be a query from your side, but you haven't generated any query, so I am asking you, what do you mean by 10/7? So first I am asking, what is the significance of 10 because of the condition? Okay, what is the condition? What will happen when the condition is fulfilled? And what will happen when the condition is not? Yes, students. What is the reply? 10 T states कब चाहिएगी? The larger value is applied when the condition is met. If it is yes, then 10. If it is not, then 7. Smaller T states are required when the value applied in the condition is not met. When this loop is not coming out, it is going in the loop, it is 7. When it is coming out of the loop, larger value is required, that is 10. Okay, count continuously decreases. There are count, तो कितने passes होंगे इसके अंदर? Count -1 because last pass I will come out of the loop. So count continuously decreases and there are count -1 passes through the loop when the condition is met. The number of T states that elapse while the count, that is C, in register C is not equal to 0 are. So how many T states are required? Student, please calculate and tell me. फॉर्मूला क्या अप्लाई होगा? जब मेरा काउंट 0 नहीं है, मतलब वापस ये लूप में जा रहा है, तो कितने टी स्टेट्स रिक्वायर होंगे? काउंट -1 तो हो गया तुम्हारा, ठीक है. दैट नंबर ऑफ टाइम्स और लूप विल बी देयर. और टी स्टेट्स कितने रिक्वायर्ड होगी? यस स्टूडेंट्स, आई एम वेटिंग. क्या लिखोगे? कितना टाइम अप्लाई होगा? नहीं बता सकते. So this should be count -1 times loop will be out, will be executed, and on the last pass through the loop the condition is not met. If condition नहीं met होगी, then it will require 7 T states. So here it will require, okay, 7 plus n-1 into 10. Avichal, I admitted you, Avichal. So I will write it in this way. Count -1 into 4 plus 10. This is not the overall. Okay, this is the number of T state that elapses when count is not 0. जब 0 नहीं है तब तक हमारे इतने states apply होंगे. After that, on the last pass through the loop, the condition is not met and the loop is terminated. This condition is not met, loop is terminated. The number of T states that elapse in this pass are 4 plus 7. I think इसमें कोमल ने काफी सही लिखा इक्वेशन. वेरी गुड. So after that 4 plus 7 T states are required. Okay, students, have you written this program in the copy? ये लिख लिया सबने? फ्लो चार्ट बना लिया? Yes or no? Because I'm okay. So we will move ahead. You can write these statements. The number of T state that elapses while Z is not equal to 0 are count -1 into 4 plus 10. Your count in the program is ffx. We all know. On the last class, it is 4 plus 7, which is 11. Okay. Therefore, The total T states required to execute the given program is, ये समझ में आया लास्ट वाला इक्वेशन विच इज वेरी इंपॉर्टेंट? नहीं आया तो put your queries in the chat box. Okay, we will discuss one more time this concept. See, we are writing a time delay program. This is a general instruction. First, we are loading the counter. टाइम डिले कहाँ प्रोड्यूस हो रहा है? टाइम डिले सिर्फ यहाँ प्रोड्यूस हो रहा है between these two instructions. So continuously we will calculate this T states only. DCRC loop, DCR FF था, F E hex हुआ, J and Z jump if not zero. जब तक zero नहीं होगा loop में ऊपर it will continuously move. So it will require their 10 T states. The smaller value is applied when the condition is not met, and when this condition is met, jump if not zero. Jump if zero नहीं है, condition क्या है? Jump if not zero. जब तक zero नहीं होगा condition will be met. Jump if not zero, condition is met. So 4 plus T, 10 T states continuously it will be required, and in the last pass, when the counter is zero, it will come out of the loop. There it will require 7 plus 4. So that is what I have mentioned here. Key when C is not equal to 0, jump if not 0, the condition is met. So it will require 4 plus 10 into count minus 1. Loop कितनी बार चलेगा? Count minus 1 times तक चलेगा. उतनी बार ही तुम ये T states को उससे multiply करोगे तो 14 into count minus 1. और last pass through the loop the condition is not met. Jump if not 0. अब कंडीशन क्या है? जंप इफ जीरो. मेरे जीरो फ्लैग जीरो हो चुका है. आई हैव टू जंप एंड लूप इज टर्मिनेटेड. द नंबर ऑफ टी स्टेट्स दैट elapse in this pass are 4 plus 7. So now I will add these values to find out the total number of time delay required to execute this program. अभी तो मैंने सिर्फ दो ही स्टेटमेंट कंसीडर किए थे, दैट इज DCR and JNZ. Is it clear? Now to calculate the total time delay, this is the program, this is the overall program. Till now I have considered this looping only. Now I will add this 7 T states. So the final statement is written over here. Any doubt? You can write it in your yes. Any doubt? Other students please reply. सिर्फ एक का ही reply आया है. How I will come to know? Okay, so written in the copy. So here I am taking that the T state required depend on the clock period, and you are taking that the computer system, the 885 based computer system requires 2 megahertz clock frequency to execute instruction MVI in 3.5 microseconds as follow. Write down the steps: clock frequency, clock period T, and time to execute MVI instruction. This is just I am telling you how you will calculate the time required for a particular instruction. So this you can write and wind up our class over here. So please write down how to calculate the time required to execute one instruction. Is it over? All of you done? Completed? I have taken your attendance. We'll continue in the next class. If any doubt, be ready with the doubts in the next class. So goodbye students. So I have taken the attendance. Don't